Okay, so welcome to the Bess working group meeting. I'll just give people a couple more minutes to get in here because I think breakfast is still finishing up. Okay, so my name is Matthew Bocci. My co-chair, Stefan, unfortunately couldn't make it to this IETF, so I'm going to try and run this on my own. So please go easy on me if it takes a while to get up some of the slides. So here is the notes well. I'll just leave it up for a few seconds for you to take a look at that. Admin, so there's a set of blue sheets going down each side of the room. Please sign the blue sheets. You come on, yeah. Please sign the blue sheets when it gets to you. Minute takers. Mankind is offered to take the minutes, but if anybody else is taking some minutes as well, please, take some, send them to the chairs afterwards. That would be much appreciated to help out. Okay, the agenda is pretty full. We've got 13 slots, including this one. So if you could, I could ask presenters to please stick to your slots. Any comments on the agenda? Okay. So I took a look at the working group milestones on our charter, and they're a touch out of date. I think these are going to need to be updated. I think they were last updated a couple of years ago. So the chairs will send a proposal to the list to update some of these. So please watch out. Thank you. So document status update. So we've had 3 RFCs published since the last IETF, which is really good going. Thank you. It's 8388, 8365, 8395. We have 2 documents in the RFC editor's queue, the EVPN overlay draft and the EVPN prefix advertisement draft. These are both in a misref state, waiting for other drafts to progress. So those obviously will move forward once the other drafts are ready. We have 3 drafts with our AD, Martin. Seamless integration, the DF election framework, and the MVPN explicit tracking. We have none in ISG review, so that's post being with Martin. We have 1 document ready for submission to the ISG. That's the VPN multicast MIB, and we're holding that to send it together with the MVPN MIB when that's ready. So we have 4 drafts who are with the document shepherd, so they've been through working group last call. We're just holding these a little bit to give Martin a chance to process the documents that he has before we do these. Well, that's largely the case. So the MVPN MIB and subnet forwarding. This we think needs a short repeat of the working group last call because there's some significant updates I think on that. EVPN optimized IR, so that's waiting for a new version to fix some nits in the draft. A VPLS multi-homing draft. So this passed working group last call a year or so ago. It really needs to be refreshed. The authors list is totally out of date. There's people with affiliations that are no longer with those organizations anymore, and we can't get in touch with some of them. And we've tried as chairs to get in touch with the editors, and they haven't responded. If you are an editor or an author of this draft, please could you contact the chairs? Otherwise, we are going to have to either ask for a new, appoint new editors, or just drop the draft. Because it really doesn't work to have non-responsive editors trying to go through ISG review and Auth 48 with a draft. You have to be, quite responsive to requests for updates to the document. So we have 3 documents that we think are ready for working group last call. That's the proxy ARP ND draft, the MVPN fast failure draft, and the EVPN IGMP MLD proxy. So since the last IETF, we adopted 3 new working group documents. The EVPN, VPWS FXC draft, MSDP SA interoperation, the fast DF recovery draft. We also have 4 documents that we are intending to run polls for adoption on in the near future. We did try to adopt the MVPN Yang document, but there were no replies during the adoption poll. So if you have read that draft, could you raise your hand, please? Two, 3 people. Okay. Okay, that's not very many. Thank you. So please, if you're interested in that, please read that draft and look out for an potential adoption, second adoption poll. There's also the EVPN PIM proxy draft, which has currently expired. Are there any of the authors or editors of that draft in the room? Do you think this is ready for adoption?
EVPN, PIM proxy.
PIM proxy, yeah.
Yeah, so we receive a lot of feedback, and we need to incorporate that feedback. So we're going to publish revision 02, hopefully before the next IETF. And then probably we need to run another adoption poll or something.
Okay.
Okay, thanks.
Thank you. So after the last IETF, we ran a proposal to park a whole bunch of very old working group documents that hadn't really moved forward for a long time. And Stefan sent a proposal to the list, and that was largely adopted by the working group. There was consensus to do this. So the drafts that are listed on the slide have been now parked. If there's significant interest in the future, we can resurrect those, of course, but they really weren't going anywhere for a long period, so those have now been parked. There's 4 other drafts that would be very helpful if there's any authors or editors in the room to give us a very quick status update on these drafts. So there's the DC Gateway draft, first of all.
Jeffrey from Juniper. EVP and IRB multicast drafts. A new revision was just recently submitted. We are still working on putting details, clarifications on some procedures. Bound procedure updates, I sent an email to the chairs that the authors believe is ready to move to the next phase. I don't know if it's quality review or something like that. Basically, we think we are ready.
You think you're ready for okay,
yeah.
Last call.
Yeah,
okay.
And also, can you go back to the previous slide? The MSDP SA interoperation, there it's also in the same state.
Okay. Yeah.
Thanks.
Manshi.
Hi, Himanshu from Siena. So we have the authors of L2VP and Yang and EVP and Yang model feel that it's ready for the last call. So can you make a last call on that?
Okay.
Thank you.
Okay, any other comments from anyone on the other drafts listed at the bottom of the slide? Oh, okay. So the first session presentation is actually remote.
I have
Sorry,
a
Ali.
comment.
Okay.
With respect to the working group last call for the EVPN inter-subnet forwarding. That was, yes, regarding the short repeat of working group last call. We had a last call, and I received some comments, and as a result, the changes that I made, some of the changes are extensive. So I like to make sure that everybody get a chance to review the whole thing. It has enough time. So I like to request make it like not a short call, but a regular call for the working group.
Like a 2-week one.
2 weeks,
Yeah,
yes.
Yeah, no
Thank
problem.
you.
Okay, thanks. So Greg, I think this is the first presentation we have is a remote presentation.
Okay, ready when you are.
Yeah.
Good morning. So this is update on this draft. The update includes, can we go next slide, please? We define the local procedure, how to advertise, bootstrap, and instantiate BFD for multi-point networks, so to track their liveness of E, and in several scenarios. Next slide, please. So updates include advertisement of BFD discriminator and for upstream P and downstream P procedures, and PEC BFD discriminator, again for upstream and downstream P procedures, and editorial cleanups. Next slide, please. When upstream P, the bringing up, we define that BFD session must include for the type multi-point head, advertise its BFD discriminator, and when it's advertised, then tails starts listening to BFD control packets according to BFD for multi-point specification. Session has, the head has to use the same IP address as the upstream PE that's been advertised in BGP BFD attribute, and leaves from the, they don't send any notifications, so everything works accordingly. So if we are taking down the session, next slide, please, then there are BGP BFD attribute can be advertised, so the BFD session deleted on the leaves. Next slide. If we have a downstream PE procedure, so to bring it up, the procedure is similar to described for the upstream PE. using BGP BFD and advertising my discriminator using the same IP address as in BFD control packet. Next slide, please. And to take him down, okay, so next slide, please. So next steps, BFD for multi-point networks now in ISG last call, and there's some discussion on issues when the last call is closed and document goes in RFC editor queue. The plan is to review procedures defined for MVPN for any changes, and then, as was mentioned, that will be ready for the working group last call.
Thanks, Ali.
Question. First, a disclaimer, I haven't read the draft. From your slides, what is not clear to me is, are we having 2 point-to-multipoint tunnel and we are having 2 point-to-multipoint BFD sessions? And if the receiving PE, egress PE, loses the primary one BFD session, is going to switch to the other tunnel? Is that the proposal here?
Yes. So each PE can be a multi-head, and it's originates its own multi-point BFD session.
Right.
So the difference between multi-point BFD and RFC 5880, so point-to-point BFD, is that the multiplexing on session is different, and that's why it's important that the source IP address for BFD session is the same as the one that is advertised in BGP.
I am not that
the
much.
Action, yeah, the
My
action
question is not that much into the how we set up this point-to-multipoint BFD session, but at a little bit higher level with respect to the switchover. Just wanted to make sure that before switching over to the other one, we make sure that the other BFD session is also on the receiving PE. It receives it and is healthy, and then we switch over. In other words, ensuring that the other tunnel is healthy before switching over.
Okay,
I mean, I can see that you lose the BFD on the primary tunnel. Okay, so if you're losing the BFD on the primary tunnel, it shouldn't be the signal for switchover. You need to make sure that the other tunnel is also healthy.
That's very good observation. And again, as you mentioned, it's outside of BFD, and this is a local policy, so which has to be explicitly mentioned in a document saying that before the switchover, you need to make sure that your other PE is alive.
Yeah, the BFD for that is exactly. Okay, very good.
Yeah, it's a good operational recommendation.
Okay, any other comments or questions? No? Okay, thank you, Greg.
Thank you.
Ali, I think you're next. Is it on?
How about now? Okay. Good morning. My name is Ali Sajasi, and I'll be going over a couple of drafts this morning. First one, the IGMP MLD proxy draft. This is, as you saw the status, we requested the working group call, and it is sitting, and it is in the queue. That answers my last question in the slide. Thank you. we within the period of since last IETF, we realized that there is one aspect of it that needs to be also covered, and I'll go over it. Can you next slide, please? So to just give you guys a background before jumping directly into solution, I'm just going to give you a background of what the issue is. We need to distribute the IGMP join and leave sync routes among multi-homing PEs. And these receiving PEs need to identify the corresponding EVI for these routes and insert these routes into those table corresponding to those EVIs. So how we did that in Rev 0, we didn't want this route to go, we didn't want it to use EVI RT, because if you use EVI RT instead of the route going to just multi-homing PEs, it goes everywhere. So we used ES import RT, which is only limited to the multi-homing PEs. And that takes care of the distribution aspects of the routes to the multi-homing PE. What it remains is when the receiving PE receive it, how to identify it. And we say, okay, let's define an extended community that corresponds to the route target. And we call that EVI RT extended community, that when receiving PE receives it, can identify the corresponding EVI. Next slide, please. So we have different type of RT, and the question is, okay, which one this new extended community correspond to? When we wrote the draft, we, as you know, we assumed that because we are doing things auto-derived, and the auto-derivation of the RT is being defined in these in the RFC 8365, that auto-derivation RT is based on the 2-byte AS, and we assume a 2-byte AS. But the question is, what happens? The operator doesn't want to use the auto-derived RT and wants to manually configure it, and wants to use, instead of 2-byte AS, want to use either 4-byte AS or IPv4 based RT. What are we going to do then? Next slide, please. So we evaluated several options. One of them was to define, to expand what we defined for the EC from just AS2 to 2-byte AS RT type to the other RT types. So define one extended community per route type, route target type. The second option was use the ES import route target and multiplex the EVI ID into that. But because we don't have enough space, we needed to truncate the ESI ID. So 3 bytes of ESI ID and 3 bytes of EVI. And we call that 3+3 scheme. And then the third one was to define a extra large RT that can multiplex the complete ESI and EVI. With respect to the first two options, the last option, we discussed it in the IDR yesterday. That relative to the first two requires more development. The first two, in terms of the development, they are in the same ballpark, and we had extensive discussion among co-authors and Eric Rosen. Over 100 emails got exchanged, and we decided that if we go with the option 1, it is the lowest hanging fruit and it satisfies what we need. And just making sure that everybody has the same assumption that what is currently implemented is based on the 2-byte AS. And we verify that the current vendors that have implemented it, it is based on the 2-byte AS. And we say, okay, if that's the case, let's just go with option 1. And it gives us backward compatibility first, and in terms of implementation is in the same ballpark as option 2. So we went with option 1, and we defined those 4 types of EC corresponding to the 4 raw target types. Next slide, please. So as you can see, we have type 0, 1, 2, 3, and type 0, which we underline, is the one which is currently specifying the draft. It is implicitly refers to that, and we made it not explicit that this is refers to a 2-byte AS, a specific raw target, and then we define 3 more extended community corresponding to type 1, 2, 3. And we added a new section also in the draft describing in case of in case of ASBRs, and we need to have raw target translation, making sure that the extended community corresponding to the raw target translations are also being done properly. So that got captured, and right now we are good to go. Everybody, all the co-authors, and everybody seems like happy with it. So that's the end of the presentation. Next slide. Just a couple of more slides. I'm going to wrap it up, and then I take actually one more slide. I just wanted to see the status of it in the queue, and I already saw it. So that takes care of that, and that's the end of the presentation. Go ahead, Sue, please.
Correction on your IDR discussion. The thing that was questioned in IDR was not whether you could do something like adding 4-byte ASs. It was the proposal on how to encode it. There is an IDR draft called Wide Communities, to which you could do that at the cost of maybe 1 or 2 TLBs and pointers. So if that changes your author's discussion, I just wanted to make sure I carefully expressed my view of what was the problematic with your proposal.
Thank you. I'm very well aware of that, and it was an option that we consider, and we are not even doing that. So we decided to go with the option 1. So that extra extended community that we had discussion yesterday, whether to do that or whether we use flexible extended community, and we had all that discussion that there is already a working group draft on a flexible EC and so forth, that is frankly is not pertinent at this point.
That's fine. Just it wasn't clear from your talk. It was a clarifying comment.
So any other questions?
Mangamna from Cisco. It's just comment, not question. So recently in multicast working group, there were discussion to absolute IGMP v1. So maybe if you want to document it in this.
Yes, I think thank you for bringing it up. I think if nobody has objection, we're going to take out IGMP v1 because basically nobody is using it. We're going to take it out from the draft. So the draft is going to be just mentioning V2, V3, and a couple of other points. I think Jorge, we discussed to change the name. I think remove the IGMP from it with respect to the sync and the leave and join, so that we need to generalize it.
Yeah.
And also reflect it throughout the draft, making sure the change is reflected. So can you please take that action item as well?
Jorge Rabadan, Nokia. Yeah. about deprecating IGMP version 1, I think is a good thing. But then we need to change all the bits in the extended community, or?
No, we're just not going to use that bit.
So we just leave it
leave
alone?
it. Yeah.
Okay.
Because there is a current implementation, so we cannot shift the bit.
That's right, yeah.
Okay. All right.
Okay. Ali, do you
Next
want-
one. All right. The next draft talks about the EVPN, MVPN seamless interop, that if we are in a situation that we are having EVPN PEs running IRB, and at the same time, we have MVPN PEs in the same DC, and we don't want to use gateways within the same DC. How do we do that? And this draft got presented about a year ago. We received some good comments, and I'm going through the resolution of the major comments that we received. Next slide, please.
You've got the
sorry.
click.
I forgot. So the main comments falls into basically these three categories. One is UMH selection in Rev 0 that we described, that was based on the source active discovery. That is not consistent with the procedures described in 65, 13, and 14. And if you're trying to do seamless integration, how does that gonna work? Then the second comment or category was falling into, for the intra-subnet. For the intra-subnet traffic, you are decrementing TTL, and also you're rewriting the MAC header. Then how is that going to be affected for the, with respect to the service? And then the third comments, third category, with respect to some clarification on the requirements section. So we go on one by one on each of these three categories. On the UMH selection, basically, what the issue at hand is if the source is being connected via via the multi-chassis lag to PE1 and PE2, or in other words, all active EVPN multi-homing, and I got the receivers on the remote PEs, as you can see in here, PE3 and PE4. Then the source can be learned by one PE or maybe by both PE, and both PE gonna advertise that they're the UMH for that source or for that rendezvous point. And however, the flow is gonna get hashed to one of the PEs. And if PE3 and PE4 exercise 6513 procedure, that procedure, it says pick up the UMH, create a UMH list, and pick it up. The first option is based on the highest IP address, and another option, which is a MOS implementation, is based on the hash. In either of them, the egress PEs, PE3 and PE4, can end up picking up a PE which is not receiving the multicast flow. And the question is, how are we going to address that? So To address this UMH selection issue, it is relatively easy in a sense that if one of the PE receives the flow, is gonna send that flow to the other multi-homing PEs in L2 tunnel. So as you can see in here, the EVPN PE1 that it receives it on the BD1, the flow arrives at, oops. Oh. Did I turn it off?
Yeah, I think. Where are you?
Okay. Okay. So if the PE1 receives the flow on the BD1, okay, it's gonna just forward it to the other multi-homing PE in L2. And L2, when it receives it, it assumes it that it has received it from its local interface. It treats that as if it has received it from the local interface. And as a result, it executes the same procedure as PE1. And then what that serves, it enables that all the multi-homing PEs serves as a UMH to the remote PEs. And they both advertise that they are the UMH for these source or for these rendezvous point, along with the VRF route import extended community. And then both PE3 and PE4, the remote PEs receive it, put it, create the list that they have both of them. And now when they select one of them, doesn't matter which one they select, whichever they select and join for a given flow, they're gonna join only one of the PEs because of that algorithm we talked about, either highest IP address or hash. And the tree is gonna build from one of these PE to the remote PEs for that flow, or if there is an aggregate tree and the tree is already there, the S, G or R, G estates gets installed, and it allows for the flow go into that aggregate tree. So that takes care of the the issue with the UMH that we have, and allows that the remote PE, EVPN, MVPN PEs receives the multicast flow and based on the exactly MVPN procedure. So a couple of things to note, that the remote PE is going to receive only one copy of the multicast traffic. Multicast traffic can be point to multipoint, so it can be optimum replication via the MVPN network, the core network. The only suboptimality in here is we are sending this multicast flow from PE1 to PE2, send a copy of it. If the PE2 already has a receiver, there is no issue, or there is no suboptimality, receives it. If it doesn't have it, then we just sending it to one PEs that doesn't have the receiver. So that's the only little suboptimality or drawback. So let me see. Should I take questions right now or wait till the end?
It's up to you.
Go ahead.
Okay.
Well, since you're already here, I'll save you a trip.
Okay. So let's say the PE1 is receiving traffic from the TS, and PE3 and 4 choose PE1 as the UNH. Now PE1 sends the traffic to PE2 on the intra-ES tunnel.
Right.
In the meantime, it needs to send the traffic to PE3 and PE4 on the MVPN tunnel. If that MVPN tunnel is also inclusive tunnel, that means that PE2 is also going to receive traffic. So PE2 is going to receive 2 copies of traffic, one on the intra-ES tunnel, one on the MVPN tunnel. It will not cause duplication in delivery, but it's just one small sub.
So the PE1 and PE2, they are EVPN PEs, right?
Right.
So they can decide whether to put the traffic into the inclusive tree or not, correct?
No, the inclusive tree is...
No, the definition that you're giving is, let's say, if you go with that definition, that all traffic goes into it, I can say that it would be the, that I can extend or expand that for the EVPN, and with respect to the multicast, if I have a joint state, then I can put the traffic in there.
Right, but that's for selective tunnel. If you are using inclusive tunnel, then that means that all your Ps will get traffic, whether they have the receivers for a particular flow or not. So just want to point that out.
Okay.
Yeah.
All right. Thanks.
Yeah, you have no choice. You're gonna get. That's what I say. You're gonna get the multiple copies, and you're simplifying the picture because the receiver can be out of P1 as well. So.
So
it's easier to fix it using better UMH selection than this.
So we'll take that under consideration. Okay, TTL decrement for intra-subnet. Another comment was as I mentioned, that given that even we are decrementing the TTL and rewriting the MAC header for not just inter-subnet, but for intra-subnet, then how does that impacts the LAN service that we are talking about for the intra-subnet? If we delve into it a little bit more, EVPN provides an emulated LAN service, not exact virtual LAN service per .1q. I mean, .1q is a 1,500-page standard that we are not compliant with, lots of the chapters of that document. So even when we limit it to a simple VLAN bridging, still we are not, if we want to go based on the exact .1q, we are still not compliant. So question, and it is the emulation that we are doing. And example of it with the EVPN, IGMP PIM proxy procedure, which is, one example of that emulated LAN service. So we are not doing MVRP, instead we are doing the IGMP proxy. And we are expanding that concept of emulated LAN service. We are saying that in this case, this emulated LAN service is going to allow for the TTL decrement for intra-subnet multicast flow. And with respect to all the application that we've come across, we don't see any issue. But again, if there are certain applications that they absolutely have to have no TTL decrement and so forth, then there is the other draft that they can use. And then clarification of the requirement. We clarified some of the requirement and added also some additional one with respect to, like, if you're adding a new subnet or you're removing a new subnet on the egress PE that it receives the multicast flow, that should not disrupt the IP multicast flow. And also, we should not, in EVPN section 6, baseline draft 7432 talks about the different interface service modes, VLAN based, VLAN aware bundle, and so forth. And we are saying that the solution should operate without impacting any of them. Next step, basically, I think it's been around 3 years since the first version got published. It has been implemented and deployed by one vendor and being planned by 2 more. And I think is at this point, we'd like to request for a working group call. Ashutosh, go ahead, please.
Ashutosh, Avi Networks. We are planning to implement this, and for the comment before made about the inclusive tree, that is how it happens in MVPN, and the intention is to not change any MVPN procedure so we can have interop with legacy or old implementations of MVPN.
So indeed, if you are using inclusive tunnel, you cannot avoid duplications. You cannot avoid unnecessary delivery, but it's just that in the requirements section, you were talking about shall prevent. So that's contradictory.
I hear you, and we'll address that offline. Thanks.
Jorge Rabadan, Nokia. So I'm glad to see that you actually addressed some of the issues of the previous version. However, I don't think we should adopt this draft as a working group document. We have the EVPN IRB multicast draft, which is covering intra and inter subnet multicast forwarding. It's also covering MVPN to EVPN interworking. So my proposal would be, why don't we focus on that draft first, try to address all your extra requirements if there is such a thing.
So let me, okay, go ahead.
And then if there is anything left, okay, we can look at this draft, but there is a significant overlapping between.
So what happens when the gateway functionality are moved to the PE edge, to the edge at the PE? So all your PEs becomes a gateway. Then what are you going to do?
Yeah, then that is already.
Then it's going to be this draft.
No, but it's already addressed in the other draft too, right?
No, when all of the edge devices becomes a PE, then it's going to translate into this.
Or the other way around, right?
So basically, if you look at it, if I have basically no gateway, because one of the requirement is not insert a gateway in the middle of a data center, okay? Because everything now we have created a bottleneck in there, and this is if we are based on that requirement, if we go with that, and we say that the gateway is not every PE needs to have gateway functionality, basically it translates into this, that we need to know the MVPN PEs need to be able to have the MVPN procedures and UMH selection and all that based on just the edge PEs, ingress PEs.
But if you isolate the gateway itself, right, where you have EVPN and MVPN, there are procedures already.
No,
in the IRB
what you're talking about,
right?
You're talking about when you talking about partitioning your network. I'm not talking about the partitioning network. You're talking about the partitioning a network based on the EVPN domain and MVPN, and you have some gateways in the middle, okay? I'm not talking about that, okay?
Right.
I'm talking about you have a network, okay? And based on that, then when you're talking about that the source is directly coming to the pair of PEs, and now that pair of PEs need to set up the MVPN tunnel to the rest of it. It is not going through any gateway. It's going to be doing the gateway functionality itself.
Can we take this discussion to the list, actually,
Okay.
because we're really over time at the moment. Just Andrew, and then I'm going to...
I have a little, can you go back for a second to your TTL stuff? My concern is with your TTL processing and stuff like this. You said, okay, if you have certain network configuration, you're doing this draft. If you have certain network configuration, you're doing the other draft.
No, I didn't say that. I said, to me, I'm not coming across any application that says you have to have TTL decrement for the intra subnet traffic of IP multicast. I haven't. So this addresses 99.99% of the application there. If you have an application which is, you come in the future, then go with the other draft. You don't have to do this.
Yeah, which means that we're pushing like TTL is such a basic thing, and having different processing based on different things is a little dangerous, especially when TTL is used also for security.
Very good. Let me ask you this. Are you saying that MVPN, wow, man, you scared him. Or you...
For a moment, I was looking for a
you
knife.
either scared him or you woke up some people's in the room. So basically, let me ask you the different question. Is current MVPN unsecure?
No, but the TTL is used in some of the multicast
for
security.
Because,
as well as
because the current MVPN does for both intranet and internet decrements the TTL.
It's consistent.
Yeah.
Yeah, that's what I'm saying. It's consistent.
So in here, we are decrementing as well. Okay. I'd like to request, that in this working group, if you can just, see who has read it and who thinks it should be.
Yeah, let's see a show of hands. Who's read this version of the draft? Okay. There's a fair number.
Okay.
Okay.
And who thinks that it should be ready for a working group call?
You mean adoption?
Yes.
Yes. Put your hand up if you think it's ready. 14 or 15, I suppose. Who thinks it's not ready? Put your hand up. 1, 2, 3, 4, 8. About half as many. Okay.
There are like about 5, 6.
8, I counted, but we don't vote.
Okay, I thought there's 6, but anyway, I mean the majority we got.
Let's take the discussion to the left, okay? Because we need to move on because we're running quite a lot over. Okay, thank you. Ali, can we have the clicker back, please? Thank you.
Sure. Hello, my name is Parag Jain, and I'm from Cisco System, presenting you this EVPN LSP ping draft. So here's just some history of this draft. It was published around 3 years ago, and it was also presented 2 years ago in Prague. The EVPN, the draft that defines EVPN routes is already now published as RFC like 7432, and also the IP prefix advertisement draft is also widely deployed now. So this draft, which is essentially defining OM sub TLVs, which are based on 7432, and also IP prefix advertisement draft, is also very stable now. Next slide, please. So this draft proposing 4 sub TLVs. First one is the MAC sub TLV, which is essentially validating the MAC state or MAC IP state, which is MAC IPs like YARP suppression table entry as well as the ARP table entries. To verify the state of these entries in the PE, which is processing the OM packet. Inclusive multicast sub TLVs for the multicast state on the P router, which is processing the LSP ping packet. And it includes both inclusive multicast as well as the P2MP tunnel-based multicast. Actually, not just multicast, also non-unicast and the broadcast traffic. Auto discovery sub-TLV is used for the multi-homing state, which could be split horizon group, as well as the aliasing state verification. An IP prefix sub-TLV is based on the route type 5, which is essentially validating or verifying the IP prefix state on the P router. Next slide, please. So we made one change from our previous version of the draft, that we have removed the EVI field from some of these TLVs, because route distinguisher itself can uniquely identify the EVPN context. So EVI is not really needed. Next slide, please. So next few slide gives the format of the 4 sub-TLVs that I talked about earlier. So I will not go into the details of these TLVs, but if anyone has any question or comment, I'll be happy to talk about them. So next slide, please. Yeah, this is the multicast sub-TLV format. Next slide, please. Auto discovery sub-TLV format. Next slide, please. And the IP prefix sub-TLV format. Next slide, please. So in this chart, we are proposing that the LSP ping packet be encapsulated using the GAL label as the bottommost label, and followed by IPv4 or IPv6 associate channel header. So this provides a uniform way on a P router, which is processing these LSP ping packet, to detect that it's the OM packet using the GAL label plus the IPv4 or v6H, and punt the packet for further processing rather than forwarding them to the customer devices. Next slide, please. So we are looking for the workgroup adoption for this draft. Yeah, question?
Yeah, Jorge Rabadan, Nokia. Just a question. So with this, basically, you said that you're checking the state. So if you send the test from an ingress P, you're checking the state of a given MAC or prefix on the egress P. But that doesn't necessarily mean that the host that owns the MAC or the IPs is alive, right? You're not proposing to, based on that, to trigger any unicast ARP or any other extra mechanism.
This is meant for the router which has announced these routes, right? EVPN routes. So these packets will be processed by the router who owns those MAC
Correct.
routes as well as MAC IP route.
But only on the P from where you send those ping messages, you already have the routes, right? So you already know that there's state in that.
Well, it's also verifying the state throughout the network as well as on the P, that there is a path, right? Because we use the same label stack that a data packet will use to get forwarded through the network to that P router. So it is, actually this draft is very much in line with the MPLS procedure that we use for data plane detection, right?
Yeah, got it.
And which has been effectively used for so many years.
I understand. But compare, for instance, to CFM that you can configure.
Interject something.
Do you see any advantage over CFM, for instance, because you can still check data path connectivity for multicast and unicast?
Let me answer that. CFM, and this is doing different check. CFM is basically doing the check at the Ethernet layer, whereas this is trying to check at the service layer, the VPN ID that you're using in the data plane that matches to what the control plane is talking about. Somewhere in the middle, it didn't get corrupted and so forth. So this is verification of the data plane to the control plane at the service layer, not at the Ethernet layer.
Yes, but if you use upmaps on the Ps, the CFM packets are actually using all the labeled stack in between, right?
How are you going to check that the given VPN label maps to the correct verb? How do you check that?
if you configure maps and MIPS on the PEs, then you need to use the same label. Otherwise, they will make it.
That tells you there is a connectivity failure. How are you going to find out where the problem is? So that's where the framework document is. The framework document talks about all these different, and there's going to be a presentation. It talks about the different layer of the OEM and what we need for each layer. And it talks about the CFM. It talks about the OEM for the MPLS tunnel and the OEM for the service, MPLS service layer. This specific presentation is with respect to the MPLS service layer. And then on top of that, you have the end-to-end customer connectivity and all the layer. Right.
Okay, thanks. Any other comments or questions? No. Okay, thank you. So it's my commander.
Good morning, and we have presented this PowerFlow DF election draft in London, and there were some changes from revision 00. So there was a feedback that PowerFlow DF election, initially we had only one DF type, which was 4, and we were using either SG based DF election or star G based DF election depending on join. But we had got feedback about having more granularity where we can have, user can basically pick either to use SG mode or star G mode. So we had distributed now 2 DF type, which is type 4 for SG and type 5 for star G. But just to make sure that even though user has picked SG mode, and if joins are coming as a star G, we are still going to use star G. It means that type 4 will be capable of doing both star G and SG, and type 5 will be only star G. So even if there are IGMP v3 join which are SG, we are still going to use star G DF election. And why exactly it was needed? There were few customers who were looking to have some kind of policy per group. So they wanted to make sure that the same group traffic doesn't get distributed among redundancy Ps. About implementation, Cisco has already implemented this draft and it is being deployed. And we think that the document is ready for working group adoption.
Okay. So if you could raise your hand, who's read this version of the draft? Okay, fair number. So any comments or questions?
Alisa Josie, co-author of this draft. This is basically one of the DF election that we need, and especially it is a must-have when you have a lot of flows into the same VLAN in case of the subscriber use cases. And this is how you're gonna load balance the traffic across for the same fat VLAN across different PEs. So it is a pretty important draft.
Okay. All right, thank you. Niraj, I think. You're doing it, right? Okay.
That's why I was keeping the clicker. Okay, so I'm going to be presenting 2 other drafts. This is one of them. This is on the EVPN unequal load balancing. And this got presented a couple of IETFs ago. I don't know whether it was 2 or 3, but there was one piece of it which was missing, and this new rev addresses that piece. So next slide, please.
You have the clicker.
I need my coffee. How about you hold it, please?
I'll do it.
Okay. So, yeah, one of those days. So, the objective in here is if I have a lag and all active, multi-homing lag, and let's say I have a CE which is dual home to 2 PEs, and each 1 gig interface to each of them, and then suddenly one of them failed. One of the interfaces fails, or one of the link fails. Then one of the PE has 2 links, the other one link, and we want to make sure that both in terms of the bump traffic and in terms of the unicast traffic, non-unicast traffic, the traffic gets load balance proportional to the bandwidth that the CE has. So these links don't go underutilized. The first part of it, which is with respect to the unicast load balancing, that was covered in the first version of the draft. And as you can see in this slide, the CE is dual home to PE1 and PE2, and they might both start with 200 gig, but then there is a failure and one of them loses 100 gig. So what we do in here, we advertise each PE advertise the route associated with his Ethernet segment, which is EtherAD per ES route, along with the corresponding bandwidth for that ES. So PE1 advertises 200 gig, PE2 advertises 100 gig, and the receiving PEX, when it receives it, it basically creates the path list for that ESI in a weighted fashion. So if PE1 has twice the bandwidth of PE2, it has 2 entry in that path list versus 1 for the PE2. And so when the traffic gets load balance, PE2 on the average receives twice the traffic that PE1 receives twice the traffic than PE2. Now, this one is for unicast, non-unicast traffic, and everything is fine. The question is, okay, for the multicast, what we're gonna do? For the multicast, we need to make sure now that the DF election procedures that is being done among the multi-homing PE, that also takes into the account these link bandwidth for the Ethernet segment. And this is what we added in this new rev, and we went and through different DF type, and one of them which was tricky was the HRW, but that worked out also well, and we incorporated the weighted bandwidth even for the HRW algorithm, and basically all different DF types can do weighted load balancing. And this is the list of the updates that we made. As I mentioned, we included the bump traffic in addition to the unicast, and we specify detailed procedures that how this link bandwidth is going to influence these different DF election algorithm. And we also added a section in case we just have routed overlay use case. And we also mentioned that we need, in case we have inter-AS, we need to have transit, this attribute needs to be transitive. Solution summary, I already went over that how it works in the figure. And just in case of the DF election, we add this extended community along with the ROT type 4 for the DF election purposes. And we added a new capability bit to the DF election extended community to indicate whether a PE can support this kind of the weighted load balancing. So again, this is basically a straightforward draft, and we address one of, we address the pending issue, and now we think that the draft is complete and ready for the working group adoption.
Mankamna, Cisco system, one minor correction. I think you have to add DF type 5 also. Earlier document.
Oh, yeah. All right, thanks. Yeah. Well, that got added after this version got out. So can you, make an action item on that? Thank you. Any comments, questions? No? I think you need to sneeze again. Okay. I guess, should we go to the no more questions? In terms of the, again, working group adoption, I mean, I know that we're having a lot of drafts in the pipe. Matthew, I don't know what you would like to do.
Yeah. Let's get a sense of the room of who's read this version first of all. If you could raise your hand if you've read this version of the draft, please. 1, 2, 3, 4, 5, 9. I've got there 9. If you've read the draft, can you raise your hand if you think it's ready for adoption? I said if you've read the draft. I'm sure I've seen some hands go up for people who didn't raise their hands for reading the draft. But it's okay. If you've read the draft and you do not think it's ready for adoption, could you raise your hand, please? Okay, we can call it for. I guess we can call it for adoption. Yeah.
All right. Thank you.
Short comment. It's probably 7th time we are asking authors of the community to make it transitive.
Yeah.
Why is it not? I don't see the authors, but I mean, it's probably 4th or 5th IETF we are doing this.
I know. I've been asking the same question.
Beat them up.
Yeah. This is, he's talking with respect to the bandwidth extended community that we are using and is defined in another draft. And it is non-transitive, and we want it to be transitive. I think if the authors remains unresponsive, then we're gonna either bring that, I don't know, bring that EC into this draft, or have somebody else pick up the other draft to push it through.
Okay.
AC, go ahead, please.
Just one more comment, then we'll move on.
AC Lindum, I'll follow up with Satya because I thought he'd gotten a hold of the offer of the previous draft. He'd worked with him in a former life, and I thought that was closed, but apparently it's not.
Okay.
Okay.
All right. Thank you, AC. Mankamana, action item for AC. Okay. All right. This is another draft on extending the mobility procedures for IRB. The mobility, MAC mobility has been described in baseline EVPN RFC 7432, and here we are extending it for the IRB, and not just the IRB case, which is there is a one-to-one MAC to IP mapping, but for the cases that one MAC can be associated with two IP, or two MACs can be associated with one IP. In those cases, which there are certain scenarios, how do we handle that? So this draft is targeted to address those scenarios, and it was presented again a couple of 2-3 IETFs ago, and here, frankly, there is the changes are just clarification changes. There is no major changes in this rev. So the mobility procedures for EVP and IRB scenarios, as I was mentioning, that if there is a one-to-one mapping, that is covered already by the baseline RFC. But if host IP moves to different MAC address binding, what are we going to do there? Or if host MAC moves to different IP bindings. And also the routed overlay scenario, what we're gonna, how we're gonna take care of the IP mobility. These are already been, captured in the initial rev, and we added some clarification to this rev. And also, the draft talks about duplicate address detection for these advanced EVP and IRB scenarios. If with the duplicate MAC detection, we already have that in baseline, but the duplicate IP detection with different MAC bindings, or duplicate IP detection in routed overlay, how we're going to take care of that is being described here. And along with these, how we're going to do the duplicate host recovery. So the updates that went into this rev is addressing the comments that was received so far, and we expanded the scope to cover routed overlay. Routed overlay means basically you don't have any MAC addresses, it's just a pure IP, pure L3, and that is uses based on the route type 5, and how we're going to cover this use case, and that it got added and described how we are doing that. And we also expanded the scope to describe the procedures in detail for the duplicate host detection. And as part of that procedure, it described the routed EVPN overlays. And then we cover the duplicate host detection for when we have MAC and duplicate IP, or when we do host recovery for the for these different MAC and IP bindings, how we do that. And we reconciled that with the duplicate host detection that was described in the proxy ARP ND draft. The solution summary, basically in a nutshell, it uses the sequence, the IP inherits the sequence number of the MAC, and if there is a if the local MAC sequence number follows the following rules, that it must be higher than the existing remote MAC, which that is the same as 7432, or rule number 2, if IP is associated with a different remote MAC, then you take the sequence number which is higher than the one from the bigger of the sequence number between that and the remote MAC. So always you pick the higher sequence number. So these procedures being described in a good level of details in the appendix, but given that we went over these procedures in detail in the last meeting, I'm not gonna, I just left it in the appendix for this session because didn't want it to regurgitate the same thing here. Overall, as I said, the mod in here, the modifications are pretty limited. And this draft has been implemented and deployed, and we think it is ready for working group adoption.
Hi, this is Wen from Juniper. I have questions regarding the one case for when the MAC is associated with many IP address, and the IP address can move to a different MAC, right? This is one of the case discussed in the draft.
Yes, IP address.
Yeah, so it was.
Well, the MAC is when the MAC moves,
IP move.
Okay.
The IP moves.
Then when the IP moves, then IP gets different MAC.
Yes.
Okay.
So, because it was proposed.
So this is IP, when it moves, gets associated with a different MAC address. Go ahead.
Yes. So when it moves, because it was proposed using the MAC sequence.
Yes.
And the sibling, it's a sibling MAC plus IP binding also update their sequence number, right?
Correct.
So I need to address case if there is you have a 2 IP move almost at the same time. This move to here, this move to here. If both bump the sequence number, it's just goes to infinitive because both are correct. Both IP moved. IP1 moved to here, IP2 moved to there, so they're gonna both.
But they're gonna inherit
Yes.
the MAC address, the sequence number of the MAC address to which they moved.
Yes. So when
So
you
the MAC, let me put it this way: the MAC, because they inherit the sequence number of the MAC, then there's in terms of the their MAC addresses, the sequence number of that is unique for the MAC. So it's not, it just becomes the MAC mobility. So do you see an issue with the MAC mobility?
So I give you an example. Let's just take one step back. Just one IP move. When IP1 moved from left to right, we're going to bump the sequence number for the MAC on the right-hand side, right?
We're gonna, it goes and inherits the MAC association, and we're gonna bump the sequence number.
Yes. So we're going to bump the sequence number from, let's say it started with 1. So both started with 1. So bump the sequence number to 2, right? Because this is the newest location.
For that MAC.
Yes. But there is almost at the same time, there is another IP move from the right to left. So both IP move almost at the same time.
Right.
They're both going to bump the sequence number from 1 to 2. Because of this IP.
But these are different IP associated with a different MAC. Or are you saying there are different MAC, right?
But there is IP, right? So
No, the IP inherits the sequence number of its MAC address. So when that IP moves from left to right, it inherits the sequence number of the MAC for which it is the local MAC that is associated with. You pick the sequence number of, it is a parent-child relationship. The child picks up the sequence number of the parents.
that's right. But
So it is disassociated when the IP moves, okay? When the IP moves and is associated with the new MAC, it picks the sequence number of the new MAC.
yes, because the IP one, we will still have the IP1 go to here, move to sequence number of 2 because they inherit that. IP1 in here, before, if you only have
No, let's
one
go, it
move,
moves to the sequence number 3, whatever. It doesn't matter, is the sequence number of the MAC. It's not the sequence number of the IP address.
yes, because the problem is all the IP inherit the sequence number MAC.
Yeah.
So the both IP, you know, you have IP1 and IP1 here. If you only have one move, this IP and sequence becomes sequence number 2. So IP1.
No, hold on a second. This is the, now you're talking about the.
I can talk with you offline.
Yeah,
let's
take
can
this
have
to
a
the
run
list,
into just it need to be addressed. This is the
No,
one.
no, that's fine. If there is an issue, definitely it needs to be addressed.
Yes, I
just
can
I'm not
work with you
clear
offline.
on that
Yeah,
issue.
I
That's
will
fine.
work with you offline on that. The
Sure.
other comment is
Can we actually take this to the list now, because we've got 5 presentations
yeah,
to do
sure.
in half an
Just
hour.
one more comment.
Could you take it to the list, please?
Oh,
Because we're just out of time, I think.
That's fine.
we've got a lot
Can
of
you send
extra
me like
presentations.
a reminder mail? Or talk offline?
Okay.
Yeah. Okay, I think
we're done.
that's it.
Okay.
Okay, this time I remember to give it back.
Okay.
Jorge Rabadán. EVPN interworking with IPVPN. This is the list of my co-authors. And well, the idea here is that you may have a tenant network that may span multiple domains. In each of those domains, you can actually use a different, what we call inter-subnet forward in SAFI. An inter-subnet forward in SAFI is actually a SAFI that is able to exchange IP prefixes. So EVPN is an example, but also VPN IPv4 or a VPN IPv6, etc. So when you have all those domains and we need to stitch them together, there are certain interworking aspects that must be clarified. So this is the goal of the draft, to clarify the interworking aspects in terms of BGP route selection, loop prevention, path attribute propagation, and also route aggregation. So what is a domain? So in the draft, we talk about domains all the time. We define a domain as the network in between two PEs, where, you know, all the routers, all the intermediate routers in between those two PEs, you're not going to do any IP lookup in the tenant space, right? In other words, two PEs are in the same domain if there are no IP lookups in the tenant space in the intermediate routers. So you have two examples in the slide. So right-hand side, you have two PEs. They are in the same domain because even though you have ASBRs in between, on those you don't have IP lookups. You don't have an IP verb instantiated. So those two PEs are considered to be within the same domain. On the left-hand side, you actually have 3 different domains. You have 2 EVPN domains and an IPVPN domain in between. And therefore, you need gateways that are able to translate in the control plane and also data plane. So in case you have different domains and you have gateways between them, you need to identify the domains with an ID. And that is also defined in the draft. Now, once you have the domains, we play with the different types of domains, and therefore we also define the terminology for the PEs. So we refer to a regular domain, to this domain where you have PEs with IP verbs, and you use only one control plane, one inter-subnet forwarding SAFI. For instance, if you look at the right-hand side of the slide, you have an example where you have 2 regular domains. In each domain, there is only one protocol, either EVPN or IPVPN. On the left-hand side, that is what we call a composite domain. Composite domain is you have a single domain, but some of the PEs, they actually support more than one inter-subnet forwarding SAFI. For instance, the interworking P on the left-hand side basically supports IPVPN and EVPN, whereas the other 2 Ps are either EVPN or IPVPN only. So therefore, we also define the role of the composite PE. Composite PE is attached to a composite domain, and it uses multiple inter-subnet forwarding SAFIs to advertise a prefix. Now, because you have all these domains and you can grow your network and stitch them all together and have multiple operators with their own domains, we had the requirement of defining a new attribute, a new path attribute that we call DPath, or domain path attribute. That is similar to an AS path, but is not AS dependent. And a good example would be what you have in the diagram. So for instance, when you have a prefix being advertised by the EVPN PE2 on the right-hand side, you advertise it to the gateway PE2. Gateway PE2 needs to advertise it to a different domain, and then it's going to attach this DPath to the route. In this DPath, we are actually encoding the domain ID and the SAFI itself, right? Now the prefix gets to gateway PE1, and PE1 will do the same thing, will re-advertise in EVPN. So at the end of the way, basically, EVPN PE1 will receive the prefix and will know exactly how many domains and for how many different inter-subnet forwarding SAFIs the prefix has gone through. So we use this to avoid loops and to have visibility of all the domains and SAFIs. The other thing we are covering is the attribute path propagation. So when you have a gateway and you receive a prefix and EVPN and you need to re-advertise it to IPVPN, what do you do with the path attributes? You can either do nothing and restart the path attributes, or you can do what we call the uniform propagation mode. And what that means is basically we pick up certain relevant attributes from one family and we actually carry them over to the other SAFI. And you can see the list on the draft, but basically when you configure the gateway for uniform propagation, we want to propagate AS path and DPath and some other attributes. The other aspect we are covering in the draft is the route selection. And this is because on a gateway PE, you can actually receive the same route, the same prefix on different SAFIs. And even if you receive it in EVPN, it can be in a route type 5 and a route type 2. So which one do you pick? So we are actually setting some rules for preference. We are even allowing, if the gateway is configured to do so, we are allowing ECMP across EVPN and IPVPN for the best paths. So this draft was presented the first time in IETF 100. It's been there for a while, getting feedback, and we've been incorporating all the feedback. The major changes in revision 1 have been, first one, we clarified the terminology section, and we did a general cleaning. Special thanks to John for doing that. We also added some clarifications for some other procedures, and we added the section on route aggregation. And in particular, route aggregation refers to this typical use case where you have, for instance, a data center where you have EVPN for layer 3, and you receive tons of host routes on the gateway. So in some cases, if you don't need host mobility across different data centers, you can actually aggregate those routes and send a single aggregate to IPVPN, for instance, right? So we are defining the rules under which you can actually aggregate those routes, or those cases where you cannot aggregate the routes. And that's pretty much it. So we believe the draft is pretty mature now, and it's ready for working group adoption. So we would like to request this adoption.
Okay. So firstly, just have maybe 1 minute for comments or questions. Could you raise your hand if you've read this version of the draft, please? Okay, that's a reasonable number. Okay, thanks.
Thank you.
So Donald, I think.
Hi, I'm Donald Eastlake with Huawei. So this is a basic draft giving sort of the foundation for EVPN OAM, the framework and the requirements for that. It really applies to RFC 7432 and 7623 EVPN, and basically leverages a lot of existing concepts, including those from various OAM RFCs and continuity fault management from 802.1q and the ITUT document on Ethernet-based OAM functions. So this should not be a terribly startling figure. This is the typical diagram showing the framework and the different layers of OAM from link up through transport network and the end-to-end service OAM. The different layers are handled by different mechanisms. Typically, the link OAM, it really depends on the link technology. And given you have an Ethernet link, for example, you would typically use the kind of OAM that you have in 802.3. Transport depends on the transport. There's choices there. There's BFD or MPLS or ICMP, depending on what technology you're using, of course. And actually, I'm going to talk about another draft, which is on BFD based OAM. The network OAM is really the sort of the PE to PE OAM. So there's more in the draft on that. It has to be able to check the data plane, of course, but also verify the data plane against the control plane, verify various forms of tunnels to support unicast and BUM traffic, tests that the split horizon filtering is working properly, and it should test that. These are requirements, and that DF filtering is working properly. The current draft provides that it has to support in-band management, and the messages need to have the same sort of entropy characteristics as the data that you want to get through, and should support both proactive and on-demand OAM. The service OAM, since what we're providing is Ethernet service, it basically uses continuity fault management for that service, and that's visible to the CEs and the PEs. And the PEs must support the maintenance intermediate point functions, and they should support MEP functions as well. And that draft also speaks about interoperable working between domains, between the actual Ethernet domain on an access circuit, for example, and the EVPN inside the service you're providing between PEs, and also working between layers, because when you detect a fault at a lower layer, you typically need to be able to alert the layer above that. If there's a link fault detected, you want to tell the transport layer OAM function. So on fault management, it talks about the different possibilities. You need to be able to do in-band per flow testing. You need to want to be able to test a representative path. There's the possibility of all paths, but due to the multiplicative explosion of paths, it's not a requirement that you be able to monitor all ECMP paths. It may not be possible. And the draft defines forward and reverse default indication and talks about them. For connectivity verification, the draft says you need to have variable length so you can test for MTU problems, and you, of course, have to be able to isolate the fault. That's one of the primary goals of the OAM function. For performance, draft says you should detect packet loss and delay, and you made it monitor jitter. So, and there are security considerations. It needs to protect against denial of service due to OAM messages. You need to be able to authenticate the endpoints so you know you're talking to who you think you're talking to, and you want to prevent the OAM messages from leaking outside the EVPN network. So this is a 00 draft, but it was actually previously draft SLAM L2 VPN Bess EVPN OAM requirements in Framework 02. So this is actually the fourth version of the draft. And I think this is a pretty solid draft. It's a good foundation for the working group to build on. And I think it would be reasonable for this to be a draft to be accepted by the working group. I was kind of rushed through it a little bit because I have a very limited time here in the remainder of this session. But questions or comments?
Just a comment. This is a very old draft, and as you know, all the OEM stuff typically gets pushed to the end of the cycle when new EVPN works gets going. Everything is on the control plane and data plane, and then the OEM is last. So given that we are getting into the stable phase of the EVPN, we are resurrecting the OEM documents in here, and they're needed.
Okay. All right. So given this is resurrection of an older draft, can you raise a hand if you've read this draft, please? 1, 2, 3, 4. There's a few. I think there's a few. Yeah, you've read it. Yeah, good. It's a good start. Okay, let's move on to the next one.
Okay, this is a somewhat shorter presentation. This is on BFD for fault management in EVPN networks. So it basically specifies how to do BFD asynchronous mode proactive fault detection, and it's in the current version covers just RFC 7432 MPLS-based EVPN, and tells how to do it for unicast traffic, bum traffic using MP to P and MP to MP. So this draft is not quite as complete. The other previous draft I talked about, the requirements of framework, has no, there's no TBDs or anything like that in it. This draft is a little bit less polished and probably needs somewhat more work, but it does cover the bases. In the current version, the draft states that it's out of scope for other encapsulations than MPLS. It doesn't cover anything to do with demand mode or echo functions, and doesn't cover packet loss or delay measurement. There are also topics that should probably be added or could be added. There's not any coverage in the current draft of anything related to any changes related to PBB EVPN. We added. There's sort of a space holder for MP to MP tunnels. If that wants to be covered, some material would have to be added. And integrated routing and bridging is also something that could be added to this draft. So it uses the EVPN LSP ping we just saw a presentation on for bootstrapping, for getting discriminators and stuff like that. And it does specify the actual encapsulation of the BFD, as you have to do since BFD has no inherent encapsulation. Specifies that encapsulation for the unicast and bum traffic. Given that this is EVPN using MPLS, it's an MPLS encapsulation. So that's just a quick summary of that draft, and people should look at it if they haven't. But, yep.
Jorge Rabadan, Nokia. So in the draft that Greg presented earlier this morning, we use in MVPN, we use BFD basically for fast failover. And he's using to distribute the discriminators, he's using actually BGP routes, right? IPVPN routes. So I was wondering why here you're actually saying that the discriminators, sorry, are actually distributed through LSP ping and not BGP routes.
Ali would like this one.
Let me take that question. Again, this is an old draft. So that was the thinking as of like a few years ago, okay? So if the distributing via BGP is a more consistent approach, and it is, we keep the same mechanism between MVPN and this one, we can adopt that approach. We have nothing against it.
Yeah, I basically have sort of taken over as the hands-on editor very recently, and if there's a desire in the working group to make changes to this draft, I'm happy to do so.
Okay. Thanks. Okay. Okay, Ron, I think you're up.
Hello, Ron Bonica, and I'm presenting draft Rosen Bess Secure L3 VPN. It's mostly the work of Eric Rosen. I worked along with him on it. The goal is to augment L3 VPN for use over a public backbone. The public backbone is both untrusted and it won't offer MPLS transport. But you have to retain the concept of multi-tenancy. That's to say, on the other side of this untrusted network, there'll be something called a C-PE, and there'll be many VPNs behind that. Next slide.
You want that?
So the basic concept is the CPE provides something called a C-PE, a customer PE. The CPE control plane is IPsec protected BGP to a secure route reflector. Private routes are advertised as VPN IP routes with private CPE loopback as the next hop. The private CPE loopback is advertised as an IP route with public CPE address as the next hop and tunnel encapsulation attribute that specifies a CPE to CPE IPsec security association. And the data plane uses these IPsec security associations. So what do we have? First, we have CPE red routes. CPEs have red interfaces back to the private site, that's behind the CPE, and black interfaces that go forwards across the untrusted network. Each CPE has a red loopback interface, private, and a black loopback interface. And CPEs originate two kinds of routes. VPN IP routes pointing out the red interfaces, red routes. They set the next hop to the red loopback, and IP route to the red loopback. We'll talk about that in the next slide. Red routes are only advertised over IPsec protected red BGP sessions, eBGP or iBGP. The red IP route, whose NLRI is the red loopback, carries the tunnel encapsulation attribute. The tunnel type is MPLS and IPsec. The remote endpoint is the black loopback. TLVs with whatever information is needed set up the IPsec SA. So you can see where we're going with this. The C-PE, the customer PE, has two loopbacks, red and black. The red one is the next hop for all the red VPN routes that are advertised. The black one is the interface to which the IPsec tunnel is anchored. So when you send a packet, it will be sent through the tunnel with a next hop of the red loopback. And actually, here we go saying the exact same thing again. In the interest of time, since we only have a couple seconds, I will jump over these slides and just go to the to the final ask, which is a call for adoption. First, has anybody actually read the draft? Okay, and I'm looking for some feedback on the draft, so that's why we'll skip ahead and use the time for that. Yes.
First of all, I really like your draft because we find it's very useful for SD-WAN applications as well. So a couple questions. When you set up IPsec between your C-CPE, -CPE, PE to the PE, do you have multiple PEs for the C-PE to connect to, or just specific one?
There is one IPsec association from, well, okay. The thing that is pre-configured is the IPsec association between the CPE and the route reflector. When you learn a route through the route reflector, then you set up another security association between the CPE and the red and the next hop of that route. And that is a different CPE. So you have to configure one IPsec association to the route reflector.
Yes.
As you learn routes, that gives you a clue that you need to set up another security association if you don't already have one to the next hop.
Yeah, yeah. Actually, my question is
By the way,
second step.
that's where we were going with all the slides that I skipped over.
Okay.
You configure one association, you learn the others.
Right, right. So my question is really, I understand that from CPE to route reflector is over IPsec, right? And the second thing is the CPE to the PE, the IPsec tunnel. Does that change all the time, or is it fixed? Is it depend on the route you set up dynamically?
Once you learn the route, you set it up and it stays there.
Stays there.
It doesn't come and go as you send traffic.
Okay.
It's not like you set it up the first time you have a packet to set, because you just wouldn't have time. It takes time to set up an IPsec association.
Okay, thank you.
Sue, tell us your name.
Sue Harris. Well, wait for this one. Okay. You're old and gray like I am.
Even older.
Yes. So you remember CARP?
Yes.
And all the keying materials and all the recommendations.
Yes, yes.
And how would you compare this draft with those?
Okay. There is some keying material that has to be distributed out of band. There's an authentication key that is used in IKE Phase 1. It's assumed that that's distributed out of band. Everything else is negotiated in IKE.
So you're not really taking the CARP recommendations from that time period.
Yeah, there's.
You decided not to do that. My question, and again due to time, is that would be good to say why not.
Oh, okay. Point well taken. We'll put that in the next version. The alternative would have been PKI, and we just didn't go there because the customer didn't want it.
Yes, PKI is normally not a routing thing. Whatever. We want the security people may fall over and choke, but the CARP was specifically targeted at this, and if you've ignored the recommendations, you ought to say why.
Actually, how does this sound as a solution? Just put it out of scope. You can distribute that authentication key however.
Again, out of respect, I think that's not, for time, I don't think you can really say that because this reads right on the same suggested scenario, if I recall the CARP. So we can take this offline, but I think you really do have to address either why you're doing or why not.
Okay, fair enough. Jeff, tell us your name.
My name is Jeff. So I know where Linda is coming from, and this question will keep on popping up, whether you could use this for distribution of keeps and seats to public keys on SD1. And either you explicitly should say it's not because it's insecure and it doesn't work for that. And probably you already said it requires some out-of-band configuration, which makes it a suitable solution. So it would be good if it doesn't, if it would be clear that it's not suitable option for what we do in SD1 space. Would be good.
Okay.
Thank you.
And I think it probably isn't, but. Jim.
Hey, Ron. Jim Guichard. Just a point of clarification. I know you're targeting secure VPNs, but the way I read the draft is that I could actually use whatever tunneling cap I want. Can you just confirm that? So if I wanted to do GRE, I could use the same mechanism, right?
Yeah, you really could if you didn't mind the fact that
there's no security.
There's no security whatsoever.
Okay, thanks. I just wanted to clarify. Thanks.
Okay, given that, still there's the call, ask for a call for adoption. The fair thing to ask for?
Yeah, let's see if you can raise your hands if you've read that first version of the draft. Okay, 1, 2, 3, 4, 5, 7 people or something. It is version 0 of the draft, so we'll see. If you could read the draft and send comments to the list, that would be great, I think.
Okay.
Thank you.
Just one comment. This is Rev 0 of the draft, right?
Yes.
Yeah. Before calling for adoption, should we run this one by the also security working group, IPsec, ME? And
Sounds
making sure
reasonable.
that, you know, we are not doing anything that is screwing them.
Okay. Well, maybe a fair thing to do is address the comment that we heard from Sue and from Jim.
Yeah.
Then run it by security and then ask for a call for adoption.
Yeah, it sounds reasonable.
Okay, sounds good.
Let's move on to the next
Okay,
presentation.
do we have time to do the next one?
You have 5 minutes.
Okay, we have 5 minutes. I'll skip over the slides entirely and just tell you what I want to do. Over the last 20 years, we've all grown old and gray creating VPN technologies, L3 VPN, L2 VPN, VPLS, EVPN, umpty-ump VPN. All of these things have a few things in common. They have CEs, PEs, VRFs, context labels, and tunnels. Let's talk a minute about context labels and tunnels. Think about a classic L3 VPN. You have a packet, it comes to the ingress PE. You look it up in the correct VRF. The lookup yields context information in an XTOP. You push the context information as an MPLS VPN label, and you push something else to get the packet to the remote PE. That's the tunnel encapsulation. Okay, we have lots and lots of choices for tunnel encapsulations. You can encapsulate an MPLS or GRE or IPsec, or pick your favorite tunnel. We only have one choice for context information. We always put the VPN label in, we always put the context information in an MPLS VPN label. Well, there are some people who would like to build PEs that cannot process MPLS VPN labels. So they're asking for an alternative. How else can I encode that information? Well, what leaps to mind is, how about an IPv6 destination option? An IPv6 destination option gets stuck between an IPv6 header and whatever comes next. So if IPv6 is your transport, you put what would have been the VPN label in an IPv6 destination option. Here's a picture, payload, context information, tunnel encapsulation, and here's a look at what the destination option looks like. It basically has 3 fields in it. An option type, the first 2 bits of the option type tell the destination what to do if he doesn't understand this option. And in this case, the behavior is discard the packet and send an ICMP message. Next is the length of the payload data. That's the, what's now the 20 bits of the VPN label. So that would be like 3. And the option data is the context information itself. Notice when we have a destination option, this length is variable. If you need 20 bits, you can support it. If you need more bits, you can support that too. In any event, here we're not asking for this as a working item in this working group, because since we're codifying a new IPv6 destination option, it has to be in 6-man, but we are looking for this group's blessing. Do we break anything by encoding this a different way? The next thing is a word of warning about what's to come. If we're going to encode the context information as something other than an MPLS label, we have to have a way to signal that between the egress and ingress PEs. So some control plane information is going to be coming in the next IETF. So it's a word of warning that it's coming. With that, I think I've used my 5 minute up.
So what is the advantage of doing this?
Okay, there are some devices that cannot process MPLS labels that people would like to use.
Today?
Yes.
But by the time this becomes a standard, they are going to be very well supporting MPLS very cheaply. I mean, here is the issue with this. This is, we are trying to take care of some hardware issue in here, and we are creating some interoperability, because right now MPLS, I can have MPLS network at one side and then IP network, and the service layer can work nicely because I'm just terminating the tunnel. Right now, I'm not messing around with the context label, and I need to do the mapping between the, terminate the MPLS complete layer, not just the tunnel, and then map it to the other one.
On one sense, I hear you. You know, everybody can do MPLS. On the other sense, some of my co-authors on this draft are building exactly those PEs, and they say they don't want to be putting MPLS on.
Okay,
them.
very
So I have
good.
to-
We don't want, no, I hear you.
Yeah.
So in that case, we don't want to do MPLS. And then we spend, what, 5-6 years on, maybe longer, on NVO3, having 4 different proposals, okay? VXLAN, NVGRE, Geneve, GPE, GUI, just name it, okay? And we agreed after the end of the 5-6 years on Geneve, and now we are doing something different.
Why does this need to take 5-6 years?
No, I'm saying there is already a standard track for Geneve. Why do I, you're saying you don't want to do MPLS. Why not Geneve?
No. Not as the tunneling mechanism, as the mechanism to encode.
Geneve does that. Geneve gives you the context label. It gives you this, VNI. It's just like a VXLAN. Between the VXLAN and the GPE and all that, they pick Geneve.
What if you're not using VXLAN as the encapsulation and there's no VNI?
VNI is nothing but the context label.
You know, the encapsulation they're looking for is...
No, all I'm saying is now you're coming with a new encapsulation. I'm pointing to that. And I'm saying that if we're coming up with a new encapsulation that we are saying MPLS is not good. We want to do some encapsulation over IP. We've done that on the NVO3, and then the question is what would be the justification? I mean, I'm just saying the bar is, we should consider a bar a little bit high. What we've done is not sufficient.
What we've done is...
Why is not sufficient? Why what we've done is not sufficient?
Okay, so the action item for me is to explain why Geneve won't work.
Exactly.
Okay, I'll take that action item.
Thank you.
Adrian.
Adrian Farrell, to follow up on that slightly, I don't think this is defining a new encapsulation. This is saying there is an IP network over which we are running. We need to carry the context. And this is actually saying, so do it without a new encapsulation. So do it without an MPLS encapsulation underneath IP, or do it without Geneve under IP. Just say, look, IP is running and here's the context.
Yes.
Okay. Yeah, I think we're over time now. So
Okay.
Thanks very much.
Thank you.
Thank you. Yes. Address these comments and then post a new revision. I think we have to ask for probably good to get security area direction review. I can just do a click on that tracker somewhere. So just send me a reminder once you've done it. That's okay. Sorry, blue sheets. We have one set at the front. If somebody has the other set of blue sheets, do you mind bringing them to the front, please? Hang on. Yeah, thanks so much. Appreciate that. Okay, thank you. lot of topics, a little bit difficult for me, so you have something. Yeah. Yeah, also